Hello, I'm Lauren, and the problem I'm going to be doing is number 35. The free fall acceleration on Mars is 3.7 meters per second squared. A. What length of pendulum has a period of 1 second on Earth? What length of pendulum would have a 1 second period on Mars? B. An object is suspended from a spring with a force constant of 10 Newton meters. Find the mass suspended from the spring that would result in a period of 1 second on Earth and on Mars. So first I'm going to tackle A, and so we know that this is a pendulum, which means that we're just going to use the pendulum equation to find the period. So they ask when the period is 1 second. So 1 second equals 2 pi, which is the formula, times the square root of L over G. And in this case, it's on Earth, so it's the length over 9.8 meters per second squared, because that's the acceleration due to gravity on Earth. And so you divide the 2 pi from both sides, you square both sides, and you times 9.8 meters per second squared to the left side. When you isolate the variable, L equals 0.248 meters, or around 25 centimeters. And next, you do this exact same process, but instead of 9.8 meters per second squared, you use 3.7 meters per second squared, because that's the acceleration due to gravity on the moon. And then next, when we go to B, now it's a spring, so it's a different equation. So now we know that the spring constant is 10 newtons over meters, and that T equals, or like the period equals 2 pi times the square root of m over k, m being the mass, which we're trying to solve for, and k being the spring constant. We can plug those values in. We know T, because they ask us when the period is 1 second, equals 2 pi times the square root of m, which we're trying to solve for, over 10 Newton over meters, which is the K. And if you isolate it out, it comes to, the meters is 0.25 kilograms. And the reason why it's on Earth, this is the answer of the mass on Earth and on Mars, is because we know that the mass, or the spring in general, they're not contingent upon the acceleration due to gravity. So that same spring will, have the same period whether you're here or Jupiter or Mars. The only things that matters is the mass and the force constants. And so we isolated out the mass, knowing the force constant and the period, which is in the end 0.25 kilograms.